So now that we've made our first circuit, let's look at adding more components to this. We've already defined an output, so let's do the next thing and define an input device. In this circuit, I've defined a button, which is powered using the 5-volt uh, supply from the Arduino board. And when I press this button, it turns the LED on. Now, this is not a physical connection, this is a digital connection. The Arduino is actually reading the state of the button and then making a decision to control the LED based off code that I've defined here. So I have two variables that I define as global variables. There's uh, the pin of the LED and the pin of the button. And then I have the LED as an output, the button as an input. I read the state of the button pin, and then I set that to a Boolean variable, which is button on. So when button on is pressed, or when it's high, when it reads a high, which is a true, it's going to set that to true or high. And then I'm going to write the state of the LED based off the button state. I can turn this on. And then we'll actually play with that a little bit inside the code to see how this works. So going back to our physical system, I still have this plugged in from last time. So the first thing I do before I make any modifications, I'm going to unplug it. So now it's, it's not that it's was dangerous to play with before, but I'm not going to break things on the board, accidentally shorting stuff out by touching them if it's unplugged. So it's not so much for your safety as it is for your equipment safety to unplug that before you start making any modifications. I also want to talk a little bit about that resistor here inside this circuit. This is what we call a pull-down resistor. And you could say, well, why can't I just directly wire my input to the button, right? Well, if I look at the circuit diagram for this, if I have the switch just tied directly to the 5-volt source, when this is opened, when this switch right here is opened, the state of the position 3 is not defined. When it's closed, it's 5 volts. So that's fine, right? But when it's opened, it's not connected to anything. So there's nothing saying what this voltage should be. And I want it to be clearly defined as either being 5 volts or 0 volts. So what I'm going to do is I'm going to put a fairly large resistor between here and ground, and that's going to pull down the voltage when this is opened. And I want to use a large resistor here because I don't really want this to draw a lot of current, right? And so the bigger this resistor is, the less current is going to flow through this when it's closed. So I actually went and I got a 100K resistor from my set. And again, this has the brown, black, black, orange, brown code, which if I go back to my codes here, so I have 100 times the orange, which is 1K, so this is 100 kilo ohms. So it's a much higher resistance than the one that I'm using with my LED, and that's because I want to really limit the amount of current going through this resistor. So I've got my 100K resistor. I'm going to put that as my pull down resistor. It's going to bring the voltage back down to 0 when that button's not pressed. Another thing that's important to note on these push buttons, these metal wires, if you look at them from the side, you can kind of see that these two prongs here are actually one piece of metal that's been bent around. So those two are always connected. It's the ones from this side, if I look at it this way, those two are separated when the button is unpressed, and when I press it, they connect. So let's make sure you put these in the right way. If you put it in the wrong way, you're basically going to short the button out and it's not going to do anything. So, be careful about how you're setting those up. So I'm going to take this so that way the two prongs that are on the same bar, the same piece of metal, I'm going to put them on the same row inside my breadboard here. And these should press down. Because they have that curvature to them, they're a little hard to get in sometimes, but they should line up fairly nicely. I suggest you do one side first and then line up the pins just by kind of pushing them in on the other side and then pushing the other side down. And they should stay fairly nicely in that breadboard once you have them there. I'm also trying to leave myself positions to be able to connect other things on those same rows as my push button. So now I need to power one side of this button. So I'm just going to plug in my jumper to the right side, or what's my right, your left, on this button, and then connect that to the 5-volt socket on the on the breadboard. So now the right side, again, my right side of this button is always going to be 5 volts. And when I push it, the left side will go to 5 volts because I'm assuming the resistance inside that button is 0 or close to 0. Now I want to have the state of the button to be able to be read. So I'm going to plug in a jumper. And I like to use my red lines for any of my high voltage lines, the different color lines for different signals, and then black for grounds if I ever have those, or when I have those, I should say. So I'm going to connect that to my pin 3. At this point, you may be asking, why are you using pins 9 and pin 3? Why not pins 1 and 2 or pin 0 and 1 and start from the bottom and work your way up? The reason I'm not using pins 1 and 0 is those pins are actually used for serial communication. And you may note that on those pins, if you look closely, right down here, there's a TX and a RX. That's a transfer and receive. So if I plug into those, I'm not going to be able to use serial communication to or from the board later on. So there's a reason that I'm not using those kind of 0 and 1s to start out with. Also, you may also note that some of the buttons have a little tilde, the little squiggly line. Those are the buttons that are able to do pulse width modulation, and we'll talk about that in a later date. But again, there's reasons to use different pins for these different things, but for the most part, it doesn't matter that much. I think other than the 1 and the 0, for most applications, you're free to use any number of pins on there. But the different pins do have different capabilities. It's just that most of the time, you're not going to worry about those overlapping until you get to more complex circuits. So I've got the signal, and now I need my pull down resistor. So I'm going to take my resistor. Again, I'm going to connect this to the same side as my signal on one end, and then the ground on the other end. And these resistor leads are thin enough that you can actually put a couple of them into the same socket without worrying about that breaking. All right, so now I've got that wired up. Again, I have my 5 volt going to my button, the other side of my button going to the pull down resistor as well as my pin 3. I still have the same circuit from last time, so I have my pin 9 connected to the anode on my LED, and then a resistor to control the amount of current going through the LED going back to ground. So now I've got that wired back up. I'm going to plug back in my Arduino. Important step. This is still running the same code from last time, so it's going to turn that LED on, right? And I'm actually going to start from my previous code. I'm just going to save this as a new code. I'm going to call it LED with button, right? And this is a good thing to be able to do, right? You usually don't want to start from scratch when you're writing something. If you have a piece of code that has some of the functionality that you're working from, start with that and then add to it or subtract from it depending on what you want to do. And I'm actually going to do this even more, so I'm going to copy and paste this first line. I want to do another global variable for my button. So I'm going to call this button pin, and I'm going to set that to 3. And this is the pin for the button. Right, so saving time by using some keyboard shortcuts to copy and paste, and then modifying what I have there. Always want to check and make sure that you have those numbers set up correctly before you move on to the next thing. So that looks good. I need to set the pin mode for my button to an input. So I'm going to copy this line of code because it already has the pin mode. I'm going to copy the button pin name, change the input to or output to input. Again, I know I get those names right when they change color, and sets the button pin as an input. Now I use the digital write here. I want to make sure this is going to go down in order. So if I want to read the state of the button and then set the state of the pin, I want to make sure I set this or do the read before I do the write. So I'm going to read, digital read. Again, looking for that color change to make sure I have both the case and the spelling correctly of the button pin. This only needs one input because all we're doing is we're telling it which button we want to read. Now I need to be able to save this because if I don't save this as a variable, it's not going to be useful to me. So what I'm going to do is I'm going to define a Boolean, which is just a true or false variable. I'm going to call it button on. And I like to use the button on because if this is true, then that means the button is on. If it's false, that means the button is not on. You could just call it whatever you want, but again, trying to use names that make sense based off of the context of what you're writing, right? So we can say read the state of the button. And then I want to turn this on or off based off the state of button on. So rather than replacing this with hi, I'm going to replace it with button on. And so this is going to read the state, set the button on state. If the read, the digital read returns a true, basically a hi, then it's going to set the button on to true. And then here it'll set that button on, the dependent state of the LED. So again, we could also invert this. So if we want it to be the opposite of that, right? We could say this was not on, right? We could do a reverse statement, and then we could change this, or we can even do math and stuff like that to do, ands or ors or a lot of different things from this. I'm going to decrease this delay because I want this to respond fairly quickly, so I'm going to wait for 0.1 seconds. And if you wanted to make your button a little slower to respond, you could do that too. Let's upload this and see how it works. All right, so we've uploaded. Again, we gotta wait for the done uploading to know that it's working. Now when I press the button, you can see that it responds pretty quickly. Now, again, we're still fairly simple here, but we can change the behavior on this. One of the things I could do is I could say, well, if I press the button, I want the LED to stay on for a certain period of time, right? So if that's the case, then what we can do is we can say, okay, let's create an if statement, right? So we're gonna say if button on, and then in the syntax of the C-based language here, right, this is going to only evaluate this if statement if the condition inside it is true, right? And then everything that runs inside these curly brackets is part of the if statement, right? So rather than running this as the button on statement, so if this is true, I'm just going to set this to high, and we're going to wait for 1 second. And then again, if I want to make this other loop shorter so that way it doesn't update quite as quickly, we can change this as well. So now here we have a conditional. When I press it, it stays on for 1 second, and then it should turn off. Oh, I don't have anything turning the button off. So we actually need to turn it off after we wait a second. Let's go low. We turn the LED on, we never turn it off. So we'll, if the button is true, so if the button is pressed, we'll turn the LED on, wait for a second, and then turn it off. There we go. Again, it doesn't matter how many times I press it inside of that wait, but it stays on. And we can get this more complicated if we want it to stay on for a cumulative number of seconds based on the number of presses or something like that. You could code that however you wanted to. But again, the advantage of this is that I have a digital input, which is going to my system. I have the code, which does whatever it needs to do, and then I have the output. Using this basic architecture, this is how you're going to create almost all of your electromechanical control. Some kind of input, some kind of code, some kind of output. So play with that for a little bit, and then move on to the next video.